All right, we're being asked to find the volume of the solid generator by revolving the region bounded by these three graphs about the line y equals 4. Okay, so let's fire up a graph. We got 1/2 x cubed. I also graphed y equals 4. That's a horizontal line. X equals 0. That's the y-axis, actually. And we are talking about a certain region. So let's take a pic of the region that we're talking about. There she is. Now, let's not forget that this is y equals 4. And that's actually the line they want us to rotate the region around. Now, the region that we're talking about is the thing that's bounded by these lines. So what's bounded by these lines? You might have guessed it by now. It's this. This is the region. We can call that region R if you like, but we're going to want to take that region and rotate it over the line y equals 4. Well, what does that mean? That means I should take a sample rectangle, and let's just draw in a simple rectangle like this. I'm drawing in one that's perpendicular to the line I'm going over. That would allow me to use the washer method or the disk method, which is the standard thing to check first. There's also a shell method where you do parallel, but we're going to do perpendicular first. Okay, if it works, go with the washer method first. Anyway, so now the thing to do is to realize we're supposed to be rotating that over y equals 4. So if I were to rotate this, it would actually just form a disk, and I could keep it going, and now it should look like a quarter or something like that, but it's a circle and there's no hole in there. So it's not a washer, it's actually just a disk. And that means we want the disk method, which is pi times r squared, but an integral right there. Now, what kind of thickness do we have here? We have a horizontal thickness, so that's a dx. So dx goes at the end of that. And what would the radius be? What would the radius of that circle be? Well, it's the same as the length of that rectangle. And the way you get lengths of rectangles, if they're vertical, is you take whatever their y coordinates are. So in this case, the y coordinate when you're at the top here, well, that's just going to be 4. And the y coordinate down here, well, I'm actually just going to say that the coordinates here are x, y. So the y coordinate there is y. So if you want the r right there, then what you need to do is subtract 4 and y. So this is what you're going to have now. Now you also got to figure out what the bounds of your integral are. Well, you're going from a small x coordinate to a big x coordinate. Your smallest x coordinate is 0, and your biggest x coordinate, well, I know that the y coordinate is 4 there, but I haven't figured out what the x coordinate is. So I got to plug in 4 for y here and solve for x. So I do that by multiplying by 2. I get 8 equals x cubed. Take the cube root, and you get x equals 2. So now I've got a dx here, but I've got a y there. So x thing here, y thing there, no good. What you got to do is replace that y right there with, well, the formula for y in terms of x. So it's now going to be 4 minus blah, blah, blah squared dx. And now the integral is ready for you to do some work on it. You can expand that first, and then you would be able to calculate that integral, because I'm not going to do that for you. This is about the setup. The setup is the hard part. Here we saw that the rectangle was touching the line. Therefore, we used the disk method. If there was a hole, then use the washer method. But always check the washer or disk method first before you check the shell method. All right, take it easy, everyone. Bye-bye.